Hi, Godspeed. I want to say in this channel that we can reach the stars. The stars are more closer than your light till now. So I believe that we can go to the stars. But in this video, I want to take on Lawrence Krauss.
The question is, what's the history of the universe look like, and we can say let's talk about the energy of the universe, and particularly the energy density of matter in the universe. Each of these galaxies weighs a certain amount, say a mass m, and the total energy of in any given region is mc squared, the mass energy of each galaxy, times the number of galaxies in the region. Okay? So that's the total mass energy in any given region. Okay? Now, because the universe, we don't know the size of the universe, it's reasonable to talk about only local quantities. So instead of talking about the total energy in any region, say of volume V, let's talk about the energy density. So we're always talking about local quantities. I'll call that rho. And the energy density is simply that total energy divided by the volume.
It is a physicist, I don't know how well it is known, but he is wrong, okay? I want to tell you that guys like him interpret wrongly the physics, and they do not know physics somehow. Many of them. And this is how they were tricked. Okay, let's see this formula. Force equal mass time acceleration. You see Newton formula. Energy equals mass time c squared, Einstein formula. And I'm telling you from this formula how much force there is in a body. This is the simply his mistakes. How much force is in this rock? But if I hit you, there's force. But I hit you again, there's force again. But then I hit you again, there is force again. The equation is this: force equal mass times acceleration. Indeed, but how much force there is in this body? The force is due to movement. The equation is atemporal somehow. It's a principal law.
The question is, what's the history of the universe look like, and we can say let's talk about the energy of the universe, and particularly the energy density of matter in the universe. Each of these galaxies weighs a certain amount, say a mass m, and the total energy of in any given region is mc squared, the mass energy of each galaxy, times the number of galaxies in the region. Okay? So that's the total mass energy in any given region. Okay? Now, because the universe, we don't know the size of the universe, it's reasonable to talk about only local quantities. So instead of talking about the total energy in any region, say of volume V, let's talk about the energy density. So we're always talking about local quantities. I'll call that rho. And the energy density is simply that total energy divided by the volume.
When you make it temporal, you put a temporal thing, a movement, temporal thing. So the Einstein equation, energy equal mass time time c squared, is the same. How much energy is in this? But if I hit you, because the energy is a property of movement, so you calculate the energy density in what? If you want to say that the electron has some energy in the electron, and you know all the electrons in the universe, you know how you are saying, like Like, you know the density, you know the energy, you know the mass, you know everything. So what do you calculate? Nothing. But you do not understand this simple thing. The energy is the movement. If you have a lake, you make it flow. And if you make it flow, you spin it on turbine, you make energy. But then you make it again to flow and make energy. Do you know energy, static energy? There is only one kind mathematically. Potential energy and kinetic energy. Kinetic energy of movement is 1.5 mass time velocity. Kinetic energy of movement. But then potential energy is not in the body, is it calculated to mass, that to know how to produce from this body hitting this body an energy of kinetic movement. And is a rotational case and a rectilinear case of kinetic energy.
The question is, what's the history of the universe look like, and we can say, let's talk about the energy of the universe, and particularly the energy density of matter in the universe. Each of these galaxies weighs a certain amount, say a mass m, and the total energy in any given region is mc squared, the mass energy of each galaxy, times the number of galaxies in the region. Okay? So that's the total mass energy in any given region. Okay? Now, because the universe, we don't know the size of the universe, it's reasonable to talk about only local quantities. So instead of talking about the total energy in any region, say of volume V, let's talk about the energy density. So we're always talking about local quantities. I'll call that rho. And the energy density is simply that total energy divided by the volume.
Maybe you do not know even this, that kinetic energy is not electric energy, is movement energy. So what electricity do you calculate on the entire universe? So you are tricked if you say that you know all the electrons in the universe, but you cannot know the electrons in the universe. And about light.
Okay, what about the other density in the universe? Well, the universe is full of radiation. All throughout space, lots of radiation. And that radiation is made of particles called photons. And so we could calculate the energy density of radiation the same way. The energy density of radiation is the number of photons times the energy per photon. Now, the neat thing is, we know from Einstein and Planck in quantum mechanics that for every given photon of light, particle of light, if you wish, the energy of that particle is some constant, Planck's constant, times the frequency of the light. That's the fundamental concept of quantum mechanics. And therefore, the energy density in radiation is the number of photons in any region times h times their frequency over the volume of the region.
There exists not all the connection between mass, light, and energy, and thermics and thermodynamics and things like this. You are being tricked, and you are tricking everybody else. How much light there is in this object? Because again, light is movement. How much light it is? I put it, how much light? So you are stupid, okay? And you are tricking the entire earth. Do you believe that the mass is energy, light energy? In this body there is light. Light is a movement. And if you make a movement, you have light. Maybe infinite light. You understand? It's like It's like temperature, thermodynamics. But if you do not know physics, you must shut up. But then I lie the entire. You are treating like this. How much thermical? This is a candle in Romanian. Okay, this is how we name this. How much can you put this thermical energy? But if you understand the water boils at 100 degrees and the temperature is a limited function, okay? But you put again, then, a cup of 100 degrees water and another cup of 100, you understand all the parameters in the physics are the same, and you cannot know anything like this. But you are not at the fault.
Okay? Now, what happens as the universe expands? Well, if an electromagnetic wave that has a wavelength like this, as the universe expands, the wavelength stretches out. The wavelength is proportional to the size of the universe. As the universe gets bigger, the wavelength gets bigger. The frequency, which is 1 over the wavelength, therefore goes down as 1 over the size of the universe. Therefore, if you look at this, I'll write it here, the energy density in photons is the number of photons times h, and then the frequency is some number, call it k, over r, and then over the volume, which is r cubed. So the energy density of radiation goes down as r to the minus 4 power. R to the minus 4 power, 1 extra power of r. It turns out if we measure the energy density in radiation today, it's way down here. It's about 1 part in 100,000 of the energy density in matter today. So if this is 1, this is 10 to the minus 5 in that units. But because it goes down as 1 over r, if we follow it back, at earlier and earlier times, it was falling off faster today. At early times, at some early time, and for all earlier times before that, it was larger than the energy density of matter.
All of you are tricked in this way. You see, you cannot calculate how much light energy exists in the entire universe. Exactly like from this candela in Romanian, okay? You see, not all the body will transform in light. Only that oil in the candela will produce light. You understand? And you understand, so you could not know. If I put another piece of mass here, it is more mass but the same light. So from light of the stars you cannot calculate even the mass and energy, and you do not understand science, okay? And you are lying. How much light there exists here? How much? Because I connected it here. You do not understand physics.
We can calculate that time, given that this ratio is 1 part in 100,000, and we find it was when the universe was roughly between 100 and maybe 1,000 years old. For all earlier times, there was more energy in radiation than there was in matter. That's what we mean when we say we had a hot Big Bang. The early universe was always dominated by radiation. The late universe, up to today, at a certain point, was dominated by matter. As long as there was 1 photon in the universe today, at some early enough time, it was dominated by the energy of radiation. In fact, there are about 1 billion or 10 billion photons in the universe today for every particle of matter, and it turns out the early universe, below a time of about 100 to 1,000 years, was dominated by radiation. So just from that simple argument, we know that the early universe was hot and dense.
How much force? So, like child, now I make a recap. How much force to massive acceleration exists in this rock? But if I hit you, you will see, and I hit you again, and you'll see. Maybe there is infinite force in this. You understand that energy is a property of movement. You understand? So if you have something to move, you will have energy indefinitely. You understand? So you are wrong, my friend, and you are tricking the entire earth. But now let me tell you in a simple way. We cannot see the universe, and I believe that we can reach the stars. And guys like you falsify science, and you lie that you know what you do not know. The stars are close, and they are not what you are believing to. We cannot see the universe, only our galaxy. Our galaxy is a sphere, not a spiral surrounded by black clouds of matter, of physical matter, not dark matter and dark energy.
Now I want to end with a mystery. And that is, this is all we thought was around in the universe until recently. But now we've discovered that there's about 3 times more energy not in matter, but in empty space. This energy in the universe is called dark energy. It seems to be associated with the energy of empty space, and what's really weird is that energy remains constant over time. And it is the biggest mystery in physics, trying to understand what this dark energy is. But I want to leave you with 2 things, one of which I'll answer in a subsequent physics, 5-minute physics, and one which is a big mystery. The first is, if we look at the fact and say this energy density is constant, what's the total energy contained in empty space in any region? It's the energy density times the volume of that region. But since the volume of the region goes as r cubed, this means the total energy in empty space increases as the cube of the radius of any region. The total energy in empty space in any volume is increasing as that volume increases. That is very strange.
By the way, you say dark energy, but if you have an anti-movement, you have an anti-energy. Because energy is defined 1.5 mass time velocity. If you have anti-movement, you will have anti-energy. What is anti-movement? You do not understand physics, you trick the earth. But let me tell you like this, simple like this, we cannot see the universe. Light diminishes with the distance. You see a body will be a point in the short time. So we cannot see the universe. That's why you are more tricking yourself. Only this galaxy. And all that they call galaxy are stars. The stars are cumulus of metallic object put in clouds of matter that surrounds our galaxy. I don't have anything with these guys. They were tricked like everybody else. But I'm telling you, we can go to the stars. The stars are close to us. One day with the speed of light. Believe me or not. And the stars are made from metals. In the old time they said that they are made from gases. They do not know how to produce light only from burning gases. Laplace said this, and you stay stupid like this. But you see that we produce light through alloys, metals, in different ways, okay? Not with fire. In old time they only knew with fire. You understand? So I'm telling you that the stars are not what you are believing now at this hour. The stars are not like our sun. The stars produce only light, and they are cold, very cold. At the space temperature cold and minus cold. They are producing only light. And what you call galaxies are cumulus of alloys, metallic objects, puts and clouds that surrounds our galaxy, that it is a sphere and it is surrounded by clouds of matter, mainly hydrogen and oxygen, like when it rains. So, my friend, I don't have something with you, but I want maybe these things will be heard. I discovered this, and I'm proving to you that you do not understand physics, how much energy exists in something. You have movement, you have energy. You do not understand physics, but not you, all of you, that you were tricked like this, were, and the light does not stretch, okay? Light does not stretching anywhere. It is not an elasticity light. Light has some frequency defined by some energy, by some property of color, like this. And it's not stretching anywhere. You stay with these stupid things invented in 1800s by guys that fought with the Bible, even with God. But I'm telling you, we can go to the stars because the stars are close to us. The stars are only one day with the speed of light. So you understand what energy is, my friend. It is not energy, time, mass, time, velocity, and you know the density, and you know the energy. It's a movement, and you can produce it anywhere when you have movement. So if you produce eternal movement, you have eternal energy. You understand? You understand? You understand? Maybe you will learn what energy is. If I have a river, I have energy. If I have an eternal river, I have eternal energy. You understand? So the energy is not due to mass that Einstein said. You don't know what Einstein said. You do not know what Einstein said. Okay? You do not know what Einstein said. And you are tricked. But I'm telling you, we can go to the stars. The stars are from always, and our galaxy is a sphere. Okay, this channel, I want to tell you that we can go to the stars. Stop lying. What is the interest? What the humanity will gain by lies? What? Nothing. I'm telling you, we can go to the stars. Stop lying this earth. And let's see what it is beyond our galaxy, because we cannot see what is beyond our galaxy. What you call galaxy are cumulus of metallic objects put in clouds, and they are simply stars and cold stars. We cannot see the universe. You understand? We cannot see the universe. And stop living in a galaxy, darling. It's a sci-fi movies and the galaxy. Stop taking science on sci-fi movies. Energy is movement. If you have movement, you have energy, eternal energy. Goodbye. God bless.
And of course, The other thing that's strange about it is that its energy density remains constant. Well, it turns out these two big mysteries are remarkable. This one we understand, and I'll talk about in a subsequent 5-minute physics. This one we understand. The wrong one. This one we understand. We understand how it's possible that the energy in any volume of the universe can increase in empty space. But why the universe is full of some energy that remains constant is the biggest mystery in science today. I went on for a little longer than 5 minutes this time, and I tried some math, and I hope I haven't lost you, but in a future episode I'll talk about this, and maybe in the next episode I'll give you a break and talk about something that has no mathematics at all. But enjoy it, and I hope you'll let me know if this made sense, and if it didn't, I'll try and use a little less math next time. Take care.